Greetings everyone, I'm Rudrak Trivedi and in today's video I'm going to be walking through the solution of internal second paper, section A, data cleaning. This is a part of the data science video assignment presented to our instructor Dr. Shaligram Prajapati. So let's begin. The first question is Bayes theorem. The probability of A given that event B has already occurred is given by the probability of B given that event A has occurred into the probability of A divided by probability of B. So this is like calculating the posterior probability of an event occurring given that event B has already occurred. So this is given by the likelihood of that is a probability of event B occurring given that A is true into the probability of A, that is the prior event that already has happened. This is our initial belief about event A, divided by the evidence that probability of B that the event has already occurred. So this is the straightforward Bayes theorem application. Let's move on to the second question. The 68 95 99.9 rule. This rule describes how the data is distributed around the mean under the normal Gaussian distribution. Specifically, the approximately 68% of the data lies within one standard deviation, 95% lies within the second deviation, and 99.7% data lies in the third deviation. So we all know that normal distribution is foundational concept in statistics, demonstrating the symmetrical properties around the mean, making it essential for data behavior in various fields. The third question is the metric that measures the uncertainty gained when replacing a distribution A with distribution B is called. This is the Kullback-Leibler divergence, measures the uncertainty gained when one probability distribution is replaced by another, quantifying how much information is lost in the process. This is also known as relative entropy, and when comparing to probability distributions, it is imperative to use this. It has various applications, specifically in comparing machine learning models. So let's progress to the next question. The ridge regression uses L dash penalty while the lasso uses L dash penalty. So the answer to this is that the ridge regression uses the L2 penalty, which basically shrinks the coefficients towards zero and not setting them exactly zero. Basically, what we are doing is minimizing the sum of squares of the coefficient. The term for this is the summation of all the coefficients squared, effectively reducing model complexity and avoiding overfitting. Similarly, lasso regression uses L1 penalty. L1 penalty is simply the summation of all the coefficients of the summation of all the coefficients, the absolute value, the absolute sum of these coefficients, which leads to more simpler and more interpretable models. The next question is a model that performs well on training data set but fails on unseen data suffers from. So this is simply the definition of overfitting. Overfitting occurs when the model performs exceptionally well on training data but fails to generalize to unseen data. This causes poor performance on the real world inputs and basically makes the model completely useless. The next question is in logistic regression, coefficients are estimated using the dash likelihood function. The answer to this is the maximum likelihood function. In logistic regression, model parameters are estimated by maximizing the likelihood function, typically expressed as a log likelihood function because of computational convenience. The next question is the hyperplane in SVM, the hyperplane in support vector machines that maximizes the distance between the classes is called dash margin hyperplane. So this is simply called as the optimal separating hyperplane, the maximum margin hyperplane. It is basically a decision boundary in SVM that separates different classes in the largest possible distance to ensure optimal classification. It is somewhat like finding a Orange that looks the closest to a apple, and apple that looks closest to an orange, and we use these support vectors to classify the to build basically a margin that separates both of these classes. The next question is, in clustering, K means minimizes the within cluster sum of. So this is the within cluster sum of the squares. This pertains to choosing the value of K in K means clustering algorithm, and a measure of compactness. This is widely used in data segmentation, enabling efficient grouping and analysis of data sets across various domains, including marketing, image processing, and so on. The next question is, in PCA, the first principal component captures the maximum possible data. Uh, in PCA, the first principal component captures the maximum possible data, maximum possible variance of the data, indicating its effectiveness in summarizing the information contained within the data set. It basically transforms the data set into orthogonal components. The first principle is the direction that captures the maximum variance of the data, representing most structure. So PCA is basically a dimensionality reduction technique that preserves the essential features for analysis purposes. The next question is, CNNs are particularly effective for dash data, and while RNNs are suited for dash data. So, CNNs, convolutional neural networks, are highly effective for spatial data, leveraging local patterns. They capture these local patterns by convolutional layers. So, it enables in feature extraction, efficient feature extraction, and in recurrent neural networks, we excel at handling sequential and time series data. They maintain a previous input record that allows the model dependencies to grow over time, right? So RNNs are basically suited for sequential data. The next question is, in TensorFlow, the structure representing operations and dependencies is called computational dash. So this is called a computational graph. So the computational computations are represented within a computational graph which defines the operations and their dependencies before execution. So this allows in optimal efficient execution and optimization of mathematical computations in machine learning models. The graph consists of two things: the nodes that are the operations and the edges that are the tensors, facilitating the data flow. The structure efficiently manages the resources during computation, essentially for large scale machine learning tasks. The next question is, Hadoop's fault tolerant distributed storage system is called. So the Hadoop storage system is basically called HDFS. Uh, the full form of which is that Hadoop distributed file system, offering distributed file fault tolerant data management. This basically ensures data reliability through replication across multiple nodes, making it resilient to hardware failures and enhancing data accessibility. As distributed file systems, HDFS can handle massive sets efficiently, enabling the storage and processing of big data across clusters of commodity hardware with scalability. So, this provides data replication, fault tolerance, interconnected meshes, and commodity nodes. The next question is a SQL query combining rows with multiple tables based on related columns uses the dash clause. So this is basic query. This is a basic SQL query. This is just the join clause that essentially groups two tables into one, and this combines data sets meaningfully, enhancing data analysis and providing deeper insights about the relationship between the primary key and the foreign key. The next question is, the Python collection that ensures only unique elements is called a. So it is called a set. A set is a built-in data structure in Python that stores unordered collection of unique elements, providing efficient membership testing and eliminating duplicates automatically. So it is mutable. The contents can change over time, and it provides basic functions like union, intersection, and differences, symmetric differences, and this makes data manipulation easy. Bootstrapping is a resampling method that samples dash replacement. So it basically samples with replacement. So bootstrapping is like a resampling technique in statistics that draws samples with replacement from the original data set, allowing the estimation of variability and confidence intervals without requiring strong parametric assumptions. So we must note that the size of the subset selected in bootstrapping is always equal to the entire data set. Thank you.